the day 3 lesson. This will be a little lesson where we are going to practice finding the area of a sector, but also, given the area of a sector, we will find other things like the area of the whole circle, finding things like the diameter or the radius, and let's see what else. We will also practice finding the area between shapes, like this gray area in number 5 and the gray area in number 6. So, and that's it. So, a short lesson today. Let's get started. So, number 1, find the area of the circle. So, for this particular problem, we are given the area of this sector, this little pizza slice right here. Anytime we are dealing with the area of a sector, our strategy is going to be part over whole equals part over whole. Sort of like this. Part over whole equals part over whole. So let us begin to set that up. Okay? On the right-hand side, we are always going to do degrees. So the partial degrees are 64 out of a total of 360 degrees for the whole circle. So part over whole. Now we're going to do partial area over the area of the whole circle, part over whole. Now the partial area is the area of this sector. We're given that. So the partial area is 220 square centimeters. The whole area, we do not know. In fact, that's the thing that we are being asked to find the area of the circle. So I like to use a capital A for the area of the whole circle, and I use a small a for the area of just the sector. So this is the setup. Now, I recommend reducing this fraction before we cross multiply. So 64 over 360, that's 8 over 45. So let's do that. So that means we have 220 over A equals 8 over 45. Okay. Now we can cross multiply. So 8A will equal 45 times 220. 9,900. So all we need to do is divide both sides by 8. So divide by 8, divide by 8, and what do we get? So our area should equal, so this divided by 8, that number's already there, so I can just hit the division sign and type 8, and I get this. 1237.5. Whoa, messed up the 5 a little bit there, but that's okay. So 1237.5, and it's an area, so we will use square units. So I will say centimeters squared. Okay, that is how we do number 1. All right, number 2. Find the shaded area. So this time we are looking for the partial area. So in terms of part over whole equals part over whole, this time we are looking for this, the partial area. So as we set up our problem, okay, part over whole, well, the partial degrees are 36 out of a total of 360. This time we are looking for the partial area, so I'll leave a lowercase a right there. Now down here I need the total area, like we found right here. We're not just automatically given the total area, but we can easily calculate it off to the side. Because we know that the area of a circle is pi r squared, where r is the radius. So if I want to calculate the area of the whole circle, it will be pi times 10 squared. 10 squared is 100, so that gives me 100 pi. Okay, so that is the area of the whole circle. So I can put that right there. 100 pi. So partial area, we're looking for that over the entire area of the circle, pi r squared, which is 100 pi. Let's reduce. 36 over 360, if I put that in my calculator or use my brain, I'm going to get 1/10. So this is going to be A over 100 pi equals 1/10. Time to cross multiply, so 10 times A, so that's going to be 10A. 1 times 100 pi is just 100 pi. To get A by itself, I shall divide by 10 on both sides like this. Kabam! So that is going to give me A equals 10 pi. Now this would be my nice exact answer. Let's see, what is this? Inches? So this will be square inches. But 10 pi is the exact area of this sector. Of course, I could get a decimal very easily. 10 pi. Okay, 31.42. Okay, and that would be the decimal approximation. All right, that's how you do number 2. Let's take a look at number 3. It says we're supposed to find the diameter, so let's just watch out for that. But we are dealing with sector area still, so we will still do our part over whole equals part over whole and see how far that takes us. We know the partial degrees this time still, so that is 70. Oh, and the total degrees will always be 360. Now I need partial area over the entire area. I know that the partial area is 210 square centimeters. All right, that's the area of the sector. So 210 goes here. Now, down here should be the entire area of the circle. I don't have the radius this time, so I can't just calculate the area directly. That's why I have to do this part over whole business. So, please keep in mind that our target is to find the diameter, but we're going to have to start by finding the area, and then we can use the area to find the radius and ultimately the diameter. I always like to reduce this fraction. That's just me. You should get the same answer whether you reduce or not, but working with smaller numbers is always easier for me. So that reduces to this. So 7 times A as I cross multiply will be 7A. 210 times 36. Seven, 5, 6, 0. All right, 7,560. Now I shall divide both sides by 7, and that's going to give me my area of the whole circle. So divide by 7, divide by 7. What am I doing? Oh, yes. Okay, so the area of the whole circle is, so I need to take this number and divide by 7. So I can just go ahead and hit divided by 7, and I get this, 1,080. Okay, and this is area, so it'll also be square centimeters. That's the area of the entire circle. Now, I'm going to need this, but this is not the final answer. Okay, now, since I have the area, what I can do is I can substitute that into the area formula. We know that the area of a circle is pi times the radius squared. So if I take this and I substitute it in, then what I will have is 1080 equals pi r squared. Now I can go ahead and find the radius by dividing by pi and taking the square root. So if I divide by pi right now, it's going to look like this. Divide by pi, divide by pi. Okay, so those pi's will now be gone. I'm just going to leave this like this for a second, because right now what I have is I have r squared is equal to 1080 over pi. I try not to get decimals until the very end if I can avoid it. That's why I'm not dividing this and getting a decimal right now. Mo decimals, mo problems. So if I take the square root of both sides right now, well, I would definitely get a decimal. And I can do that because I'm so close to the end. But understand this. By taking the square root of both sides, now I have the radius. Okay, so basically the radius is equal to the square root. I'll go ahead and get kind of the decimal right now. So square root of 1080 over pi. Let's go ahead and do that. So the square root of 1080 over pi. Okay, so that gives me 18.5412. Okay, 18.5412. I'm not actually going to use this number. I am going to use what is in the calculator. Whoa, wrong button. I am going to use what is in the calculator, all the decimals. But I know that if I know the radius, then I can get the diameter by doubling it. So I need to take this and I need to multiply it by 2. Okay? Because whatever the radius is, if this is the radius, then the diameter is the whole thing. Okay? So if the radius goes from just here to here, then the diameter is the entire way across. So the diameter will always be twice the radius. So I need to take this radius, multiply by 2, and I will have the diameter. But rather than rounding, I can just take this number that's already in the calculator and just hit times 2. So now, this is the first time I'm rounding, and it's the very last step. That's what you should always try to do. So 37.08. And this is going to be centimeters, because it's only length, so it will not be centimeters squared. So this is the final answer for number 3. Okay, let's go ahead and do number 4. Find the shaded area. All right, so we're finding the area of a sector. This problem is looks just like number 2. Find the shaded area. But wait, there is one very tricky difference. On problem number 2, we saw the 36 degrees, and we went 36 over 360, and we did the whole thing, and we cross-multiplied. On this problem, we see the 120 degrees. Now, if I were to do 120 over 360 right now, that would be wrong. Wrong, warning, alert. Why? Why is this wrong? The key word here is shaded, the shaded area. This 120, look where it is. It's in the unshaded area, the white zone. Looking back at problem number 2, this 36 degrees pertained to the shaded area like it is supposed to. So we could just use the 36. But the 120 is not the right angle, so we cannot use it. Instead, we need to subtract from 360. Okay, so if we do 360 minus 120, we find that the rest of the circle is 240 degrees. So in fact, that is the angle that we need to use. This giant angle that wraps all the way around 240 degrees. That's the one that we need to use. So we will do 240 over 360. And now the rest of it, part over whole. We're looking for the partial area, so we'll just call that A. The whole area, we better be able to find it. Let's calculate it off to the side here in green. Maybe I'll make a little bubble for it. All right, here we will calculate the partial area safely within the bubble. All right, because we know that area is pi r squared. So in this case, area is pi times 20 squared. So that means the area is 400 pi. So we will take our 400 pi and we will put it right there. 400 pi. Now we can go on with the problem. Simplify, cross multiply, all that good stuff. So 240 over 360, let's reduce that. Whoa, I missed the button. Try again. 240 over 360. 2/3, nice, very nice. So that's going to be A over 400 pi is equal to 2/3. Lovely. So as I cross multiply, that's going to give me 3A. 2 times 400, of course, is 800. Okay, so that'll be 800 pi. Please don't forget the pi. Okay, so all I need to do now is to divide by 3. So if I divide by 3 on both sides. Now this is the exact area right here. Okay, so if you are asked for the exact area, what you would put is 100 pi, 800 pi over 3, let's see, square meters. So this is the answer, the exact answer. Okay, but of course we can put that as a decimal if we want to. So 800 pi over 3. Notice it doesn't reduce. So that is 837.76. meters squared. So this would be the decimal approximation for the area. So that is how we do number 4. Again, the big thing to watch out for is this 120 degrees was in the white area. We have to make sure whatever angles we're looking for are the correct ones, the shaded ones. Like number 3, that was okay because 70 was shaded. So please watch out for that. Okay, moving on to the last segment of our lesson. Finding the area between two shapes. Now, the key to finding the area between two shapes is this. The shaded area, you know, the space between, is always going to equal the outer shape minus the inner shape. Okay, if I have the outer shape and then I subtract the inner shape, that should, you know, sort of like cutting it out with scissors, that should leave the outline. So in this case, the outer shape is the circle. Okay, so it's the circle minus, and the inner shape is the square. So this is my strategy to do the circle minus the square. Now keep in mind the formula. So for a circle, the area is pi r squared, so I'll be doing that. For a square, the area is base times height. So I will be doing that. Now, the circle part is easy because all we need is a radius, and there it is. So this is going to be pi times 9 squared. So we're all set up for that. Now, unfortunately, the square is going to take a little bit more work. We have this 9, but that's not the base, that's not the height. So we're going to have to do a little bit more to find the base and the height. And here's what we need to do. In a previous unit, we learned about 45, 45, 90 triangles and the special relationships that they have. And we learned that if we have a 45, 45, 90 triangle, whatever the sides are, or which are the legs of this right triangle, the hypotenuse would be leg times radical 2. So if this was x, this would be x, always isosceles, and the hypotenuse would be x radical 2. Okay, focus on this x radical 2 with me. Okay, focus on that, x radical 2 for the hypotenuse. Now, I'm mentioning that because anytime you take a square and you split it, you are going to get a 45, 45, 90 triangle. So as I take this and I look at the diagonal of the square, I'm hoping that you will see that what I have here is a 45, 45, 90 triangle. Okay, because this is 45 degrees, and so is this. Now, remember the pattern from the formula sheet here. It goes like this. We need to know what the sides are, so let's call them x. We know they're the same. Well, that means that the hypotenuse here is going to be x radical 2. Okay? All right, but we know that the hypotenuse is 18. How did I know that? Because I see the 9. Okay, and the 9 is a radius. So if I go the whole way across, that'll be another 9 for a total of 18. So I just did 9 times 2. So these two must be equal to each other. Okay, the x radical 2 is an expression for the hypotenuse. 18 is the known length of the hypotenuse. So off to the side someplace, all right, I will make this little equation. X radical 2 must equal 18. So then I can just divide both sides by radical 2 to get x by itself. And it turns out that x is 9 radical 2. Okay, that means these sides of the square are 9 radical 2. Okay, that means this is 9 radical 2 and this is 9 radical 2. Well, guess what? Now we know the base and the height. They're both 9 radical 2. So back to the problem, I wanted to do base times height to find the area of the square. And now I know it. So that's 9 radical 2 times 9 radical 2. Okay, let's simplify this as much as possible. So 9 squared is 81, so that's 81 pi minus 9 radical 2 times 9 radical 2. Let's see if the calculator will do this properly, because I don't want any decimals yet. So 9 radical 2 times 9 radical 2. $162. Look at that. Okay, now that would be the exact answer. It will not simplify any further. This has a pi, this doesn't. I cannot subtract 81 minus 162. That would give me a negative number anyway. So we are talking about area, and this was feet. So I could put units on here, feet squared. But anyway, maybe I'll stick it over here. That is the exact answer. But often you really want a decimal. So let's follow through and get a decimal. So 81 pi minus 162. 81 pi minus 162. And we get 92.47. Square feet. Okay. So we have the exact answer and our decimal approximation. That is how you do a shape inside of a shape. Okay, it's always going to be the, to find the space between, you will always find the area of the outer shape and subtract the area of the inner shape. Alright, so watch out for that. Finally, number 6. Again, this is the space between two shapes. Number 6 is a little bit simpler since they are both circles, but I'm still going to be careful. So if I want that shaded area, okay, this shaded area, like we mentioned before, should equal the outer shape minus the inner shape. Alright? So in this case, they're both circles. So we're going to find the area of the big circle and we're going to subtract the area of the small circle. By the way, see how I make these little diagrams and I set it up and I do, if I'm going to do circle minus square, I make a circle minus a square with symbols, pictures, sort of a picture equation. You should always do that, just like me. So anyway, in both cases, since they're both circles, the area is going to be pi r squared. Alright, not a lot of room for that one, but pi r squared. So, let's do it. Now, for the big circle, I have to be very careful about my radius. Most kids can see pretty easily that the radius of the small circle is 8. Okay, since the diameter is 16, the radius here is 8. So when it comes time to do the small circle, and we have to do pi times 8 squared, they get that part right. But then some kids will mistakenly think that the 7 is somehow the radius of the big circle, and they'll want to put pi 7 squared next. No, 7 is not a radius. It does not go all the way across. But what we can do is draw a radius of the small circle right here to help us see what's going on. And if we see that this is 8, then that might help us see that if we want the total radius of the circle, we're going to have to add these together. Okay, so this is 8, and then that's 7, so that's a total of 15. So the radius of the big circle is 15, not 7. So this will be pi times 15 squared will be the area of the big circle. So 15 squared is 225. So that'll be 225 pi. 8 squared is 64. So that'll be minus 64 pi. Now remember here where we had to stop for the exact answer? That was because these were not like terms. This one had a pi, this one didn't. Notice that both of these have a pi. Okay, so these are like terms. So I can combine these. Your calculator probably even knows this. So 225 pi minus 64 pi, that's 161 pi, like terms. So our exact answer will be 161 pi square meters. Okay, so that is our exact answer. Of course, then we can go ahead and get a decimal approximation using the toggle button. So 505.79 would have to round up to 80. So 505.80. Okay, So that is how you find the area between two shapes. You just take the area of the outer shape and subtract the area of the inner shape. Use your picture equations to help you keep your work organized. All right, I hope this lesson has been helpful to you. If it has helped you in any way, please give me a thumbs up. Hit that like button for me, and I really appreciate it. I will see you on the next video.